Let's start to explore imports and decorators here now. These are reasonably new language features in JavaScript that we use extensively in Aurelia. So we'll look at them independently of our user framework for the moment. So imports, you're familiar with imports in JavaScript using the require construct. We're not using require in Aurelia. We're using a more modern version of imports, which we'll tour briefly now. They're not dramatically different from the way imports work in Java, so you'll be familiar with general concepts. Decorators, again, we have something quite similar in Java. We've been calling them annotations, so we'll just review how they look in JavaScript. And dependency injection is the third thing we need to look at. This is another pattern. It's not a user experience pattern, it's a general software engineering pattern. And the Aurelia framework makes use of that pattern to give us quite an elegant mechanism for wiring up components once they're launched. First of all, imports. This is the general idea. We have the word import. We identify something we want to import, the word from, and then the module name. We saw it in the Aurelia 1 lab already. We can import more or less anything that's been exported from a given module using the syntax. So we're looking for the name that the object will receive the imported values, name of the exported members, possibly default names, aliases, and module names themselves. So it's quite a rich syntax, a lot of options possible in terms of how we master it and we import it, including wildcards, including renaming of values that we import. We'll be using it in a much simpler mode though. Let's have a look at that. So first one, import everything as my module from my module. So it'll import the entire contents available directly into our application. Second example, importing a specific entity from the module. So we're only getting one. And here we're importing two entities from the module. In general, we would prefer to use the latter, that is to explicitly import what we want rather than doing a blanket import. Again, similar guidance and recommendations in Java to that effect. Here is an example of us possibly doing some renaming in the first example here. Here, really long module name will now be known as short name in the module. Second example is importing, which may run some initialization, but without importing any specific entities. We've been kind of doing something like that when we've been importing the database, you might recall, in our Happy application. And finally, another example of importing two different long values and having them renamed. One final example then. Suppose we've got a file.js. Just looking at it here. This is one file on disk. It's got two functions. One of them is imported, the other is not. So by default, functions you declare in a JavaScript module are not exported unless you provide the export statement, export keyword as you're declaring the function in this instance, and then that makes the function available when you do your import in another module somewhere else. Okay, that's all entirely logical, and I don't think there's any challenge there really. Just one point on Node. Node is moving towards this model. That is the require syntax we've been using. It will be replaced by a syntax pretty close to this. So we're unifying both module systems. That's welcome, I think. It means that we can, both Aurelia and the other frameworks will all use the same module import syntax. Secondly, you want to look at is decorators. You already are familiar with this. Perhaps you've seen decorators used for unit testing or we've seen in Java, that is, we're able to insert annotations inside a unit test file to say this is a test or it's a before or an after. You may have seen annotations used in Java for databases, for instance, annotating a class for one-to-one, one-to-many, many-to-one, etc. Well, in the new version of JavaScript, we have something similar, even the same syntax, the at notation. We can decorate individual methods in classes or decorate entire classes. Indeed, you're seeing an example there of testable. Perhaps these decorators can be used by the testing frameworks we're using. Now, the third thing we want to look at is dependency injection, and this is something we haven't really seen much of in the labs to date. And it solves a problem really that we perhaps haven't had so far, but we're using a powerful framework now like Aurelia. It makes extensive use of dependency injection to simplify how objects communicate. Remember, we may have many view models present in our application, and we may have important state to be shared across those view models. Trying to orchestrate references between these classes can be quite a challenge. Dependency injection is a solution to this predating JavaScript even. It's widely used in Java currently, and Aurelia comes with a dependency injection framework which we will be using shortly. So if we have two services, A and B, and the class A has to use those, it has got to acquire a reference to them somehow. With DI, we inject the reference directly. So we could have accessed a locator to try and acquire a reference to these services. The locator could have recovered the service for us and made it available to us. DI replaces the need for a locator in this context. Now, how it does this is behind the scenes really. We don't need to worry too much about it. There's various processes involved in assembling and acquiring the services we want to allocate, finding who's using them, injecting them directly in. You can discuss that or read about that on the Wikipedia page. Here's how we will be looking at it though in Aurelia. It's actually reasonably simple. In this example here, we have got a customer service object we would like to use. That customer service object perhaps is used to communicate with a backend. We would like all of our view models to be able to access that customer service. We don't want the view models involved in figuring out where customer service comes from, how do I start it, how do I initialize it. We just want them to use it directly. The notation in Aurelia is to bring in the inject annotation or decorator we just talked about, and identify the class of the service we want to use, and then match that with a constructor that accepts a customer service object and stores it in the class view model in this instance. Just to emphasize that again, the decorator for the class specifies the type of the service we would like to consume. The constructor, and there must be one, accepts an instance of that service, and usually, it's not mandatory, but usually we store that instance inside our object. I think it'll make a little more sense when we get into it in the lab. there are two types of service that we could be seeking access to. A singleton service, which would be one instance that everybody's sharing, and a transient service, which would be one that could be created as needed. We'll be happy in our examples to only be using the singleton service. So going back to the previous example, there will be one customer service object created by the system for us, and anybody who wants it can have it via injection. And that means you introduce the annotation, and you have in a constructor a parameter that accepts the service, which we usually store as a field. We can use that then subsequently in our view model event flow. For instance, down here we could be retrieving information from the backend service because we have it injected in the constructor. Okay, so they're more general features really. Imports are part of the newer ES6 standard, or ES Next as Aurelia likes to call it. So are decorators. So both of these are part of the standard JavaScript environment, and both actually are or will be available in Node. Dependency injection is a little bit different from these. It's a design pattern that Aurelia implements to simplify the initialization and wiring up of components as we assemble them. Okay, that's it for now. We'll talk to you again soon.